Hi everyone, good morning. Welcome to our lesson for today. So today we're going to talk about VSEPR numbers. So what VSEPR numbers are is they tell us the shape, or the 3D shape or molecular geometry is the fancy term for it, of how an atom looks, because all these exist in real time in 3D. If you look online, when we mention these shapes, you can actually see what they look like. If we were in school, we have a modeling kit that we use. Now, if we have time, if we get back at the end of the year, we'll try to use it so you guys can see these shapes. I don't recommend running out and buying a kit because they cost about $30 to $40, and there's no need for you to spend that kind of money unless you really want to nerd out. If you want to, hey, go ahead. Okay, so VSEPR stands for Valence Shell Electron Pair Repulsion. Okay, so what it really is it's a 3-number set that tells us the shape. So our first number tells us the total number of bonding areas or domains. We use that term area or domain interchangeably. That can refer to either a lone pair or a bond. A single, double, and triple bond all count as the same thing. Okay, the second number tells you how many areas or domains are bonded, and the third one is how many are lone pairs. So when you look at your Google Doc, it's going to look like you have a lot to do. You really don't, because all the Lewis structures should have already been done by you. So you don't need to do them again. All you have to give me is just the VSEPR number and the shape. So don't drive yourself crazy. I hope you save the papers. If not, if you go in Google Classroom, you can see your pictures and go from there. Okay, so I have CH4. I'm going to draw these real quick, except the exception ones with the extended octet I'll go over a little bit because I know some people had trouble with those. So I have CH4. Okay, I look around my C because I only care about the central atom when I'm doing these. The outside atoms don't matter, no matter what they are. So I have 4 H's, so I have 4 bonding areas. All 4 are bonded, and 0 are not. If you look all the way at the bottom of your Google Doc, it's going to give you a table that gives you all this. It's also in the back of the white periodic table if you have it in the top left corner. You will never need to memorize these. I will always give you this chart. So don't worry about needing to memorize them, just know how to read it. So 440, you look on that chart, it says tetrahedral. Now, I learned to do it with the dashes in the middle. If you just wrote 440, that's fine. Okay, but you have to make sure you have all 3 numbers. Okay, let's try NF3 next. So I have N with 3 Fs. Remember, the side you put them on does not matter. Okay, so I look around the N, and I have 4 bonding areas, because I have 3 Fs, and I have 1 lone pair. So my first number is a 4. 3 of them are bonds, 1 of them is not. And how you can double check a VSEPR number is the first number is the sum of the last 2. So you can either do 4 minus 3 equals 1, just like 4 minus 4 equals 0, or you could go backwards to check. 1 plus 3 equals 4. If they don't add up right, you messed something up. So when you look at this, look in your chart, it's going to be something called trigonal pyramidal. And it almost looks like a camera tripod if you look in 3D. Tetrahedral is if you had a tripod and another part sticking up above it. Okay, SiF4. Okay, I'm going to put in my dots. Okay, I have 4 bonding areas. 4 are bonded. 0 are not, so that's 440 tetrahedral. You're going to notice the same shapes always come up because there's really not that many on that list. Okay, let's try a polyatomic here. PO4, 3 minus. So I have my P with my 4 O's. Okay, distribute my electrons. Don't forget your bracket because it is a polyatomic ion. Minus 3. So I have 4 bonding areas. 4 bonded, 0 are not, so that's tetrahedral again. Okay, let's try NH3. So I have my N with 3 H's, and then I will have 2 electrons up here on top of the N. Okay, so I count my bonding areas. I have 4 total. 3 are bonded, 1 is not. So they're 4, 3, 1. Trigonal pyramidal. Okay, NH4 ammonium. So I have N with my 4 H's. I need my bracket for this one because it has my charge. So I have 4 bonding areas. Okay, 4 of them are bonds, 0 are not, so tetrahedral. Tetrahedral is one of the most common ones that you'll see. Okay, let's try one of the exception ones that we, very similar to what we had. Excuse me, so I have 3. So F has 7, 7 times 5 is 35, plus 7 from I is 42. So I have my I in the middle with my 5 Fs. Okay, so I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Remember, any extra ones go to the middle I, go to the central atom, okay? You just, the outside ones can never handle more than 8. Any extra ones go to the middle. Remember, don't put them on top of a line. Don't split them up. They go together as a pair. Just pick a spot and put them. So I look around here, and I have 6 bonding areas, because I have the 5 Fs, and I have the 1 lone pair. So my first number is 6. 5 of them are bonds. 1 is not. So when I look that up, that's what's called square pyramidal. Okay, let's try ClF3. So F is 7, 7 times 3 is 21, plus 7 is 28. Okay, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, so now I look around here. I have 5 bonding areas. I have 1, 2, 3 Fs and 2 lone pairs. The pairs count as 1. So my first number is 5. 3 of them are bonds. 2 are not. I look at 5, 3, 2, and it's called T-shaped. And I happen to draw it like that because I've been doing this for a while. You can see it kind of looks like a T, and that's how it looks in 3D space. Okay, we're actually going to jump to my other whiteboard because I want to show you some other ones too. These ones are not in your notes, but they may be very similar to what you have in your packet to do. Okay, let me just get the other light because it's a little too bright on this side. Okay. So first off, if you have any molecule that only has 2 atoms, you don't need to do a VSEPR number. If you write one, I'm going to honestly just ignore it because you really can't do them. If you just have 2 atoms, you just write linear. And I'll give you credit for the VSEPR number because you didn't need it. You just write linear because the only way 2 atoms can look is a line. There's no other way about it. Okay, let's try CH2O. So I have C with my 2 H's. Okay, I'm drawing my electrons. So I look around it, a double bond counts the same as a single bond. So here I have 1, 2, 3 bonding areas. All 3 of them are bonds, 0 are not. Trigonal. Planar. Okay, let's try NO2 1 minus. Now I'm not going to show both resonance structures, so you guys should know how to do that at this point. So I have my N in the middle. Okay, so it should look like that. And don't forget your bracket because it is a polyatomic that has the charge. You could draw your resonance structure if you want, but it'll give you the same answer when we're talking about just VSEPR numbers. So I look around the N, because I only care about the middle atom, remember, just like I only cared about the C over here. And I have 1, 2, 3 bonding areas. The single bond counts as 1, the double bond counts as 1, and the lone pair counts as 1. Okay, so my first number is 3. How many of them are bonds? 2. Because the single bond and double bond count the same, okay? Double bond and triple bonds count the same because it's almost like if you're holding one hand versus someone versus you're holding 2 of their hands, it's taking up the same space in the air. And triple bond is kind of like if you had a third hand. You're still taking up the same space in the air, you're not taking up extra space. Okay? And I have 1 lone pair, so 3, 2, 1, and that's what's called bent geometry. Now if we have one like C3H6, sorry, not C3, let's make it C2. So if you have one like this that has 2 middle atoms, it's going to be symmetrical. You just break it right in half. We only look at one half or the other half. I'm just going to happen to choose the right half. So when you do this, you look and you say, okay, So my C has what around it? Oh, 4 bonds. 4 of them are bonded, 0 are not, tetrahedral. You don't have to do both sides, you only can just pick one because I'm not going to give you any molecule that would not be symmetrical. Okay? So for example, CH2O, yes, there is a resonance structure that could look a little bit different. I would, I'm looking for the one like this because this one's a little more balanced than having an H on the C and H on the O. Remember electronegativity, how much an atom wants electrons or how much it can attract them. O is more electronegative than C. Let's go over a couple common mistakes I keep correcting for people. And let me first of all put one, it's not even on this list, and there's only a couple people who are still doing it. So when you guys see me taking off points when I give you feedback, and of course you can resubmit and get your full credit. Some people have been doing it, some people haven't. That's your choice. You have to use lines to connect atoms. If you put dots here, I'm gonna mark them wrong, because that's not how we show it at the higher level of high school, and that's not how they show it in college usually. So if you've been connecting them all, like you put 2 dots here and 2 dots here and 4 dots here, they're gonna be getting marked wrong. Okay, that's only to a few of you guys if you're watching the video, but make sure you're not doing that anymore. Okay, so first common mistake. People are putting brackets for the polyatomic ions. Make sure that you do. Second, not pairing electrons or putting them in the same space of line. So maybe some people are putting 1 dot here, they have to be paired up, and they can't be the same space of line. So you can't put them right here, for example. You can't put them right here. You can't put them somewhere where you already have a line. That space is already occupied. Okay? Using too few or too many electrons. You have to use all the electrons you're given. You can't leave some out. You can't use too many. Remember, mom gives you like 20 or 25 bucks to go to the mall and says she wants change back. You're not going to spend more money than you have. You only have that cash, and your goal is to not bring any change back to mom. You want to use up all the money you have, so you have to use that number, okay? And so it's always going to be even number 2. If you notice yourself coming out with an odd number, you mess something up, go back and check your count again. Okay, and atoms can only have 8 electrons, except H in the extended octet. So check to make sure they all have 8. So I'm looking here, okay, H is only 1 a line, that's fine. They don't get dots, they just get a line. This C has 2, 4, 6, 8. The O has 2, 4, 6, 8. Always check. The only ones that it doesn't count for are those extended octets. And you better tell because something looks funny. You have way too many electrons to know what to do with. And even then, your outside atoms get just 8, but it's your central atom that doesn't. On a quiz, I'd only give you 1 of those. Okay? So if you have any questions, please tune into our live lesson at 9:20. The link will go live about 9:15. Or if you have a question that you think isn't being answered too well through email, through my comments, shoot me an email. And if I have a few people who want a question and answer session, I can always set one up in the afternoon. Okay? Have a wonderful job, guys. And I know this video seems long. If it makes you feel better, I did this entire thing before realizing that it wasn't in the right mode. And I thought that I started a video camera, but I just took a picture of myself at the end of it. So hopefully your day goes better than that. Enjoy the video for today. Take care. Bye.